do. And as you see, the device I'm actually connected to is in a state backup, and the master router is the second router in front, which is the 100.20. So it got high priority configured, but we don't care about this priority. So I will launch the tool up again and connect to the right network, and you will see there is the hot standby blinking, and there are some VRRP connections visible to the tool. So this actually is the connection. It's handled by the 100.20, and the virtual IP is the 100.2. It got the priority 254. So what I will do next is doing a lot of pings from the one router to the virtual IP. While these pings are running, I will take over that IP address, and you will see there is only one ping missing, and all the other packages got directly forwarded to my notebook. So I will do a ping on the virtual IP address, which is the 100.2. I will repeat them sometimes. So, and while those pings are running, I will just take over the IP address. So now you see there is one ping missing, and afterwards all those other ICMP packages are now answered by my local host, not by the second router, which should be the master device. We can easily prove this if we take another look on the output of the show VRRP, and you see the master router now isn't the second router in front, but is my notebook, which got the IP address 100.100, and also the priority raised up to the maximum value, which is the 255. So as you see, it's kind of really easy to overtake an high available IP address if you see those VRRP traffic in your client network.
Okay. So, for VRRP, there are also, like for some routing protocols, there were some authentication mechanisms, but they were removed in a newer version of the standard because they analyzed all the scenarios, and they mentioned, okay, if you use that, you more likely have denial of service by authentication not working properly or something like that. So both of the routers think they're the master, have the same IP address, and then that's it with your connectivity in that network. So they just removed it, and there's no really authentication in this protocol anymore. Good. Last but not least, the BFD. I have to speed up a little bit, so I will just scratch on that. We also don't make a demo on that, but unfortunately it's implemented. BFD, it's called bidirectional forwarding detection. It's, let's say, an add-on to the routing protocol because of the need of a faster now I'm missing an English word. Faster, let's say, repair time for network protocols. So if a link goes down and it was your active route to a certain destination, it takes some time until the routers are noticing that the link is down. If it's a direct link, they pretty much notice it because you pulled the cable, so there's no link anymore. But if it's behind another router, they don't get that information. It can take some based on depends on the configuration, can take some seconds, can take some minutes. But there are, in some environments, there are requirements to do this a lot faster. And actually, the routing protocols don't support that. So there was some kind of add-on. You can use it with different routing protocols. They can send, similar than the hello packages routers send to each other, they can send like something like hello packages every 50 milliseconds. So they can repair the network. If something happens, they can really detect it really fast, let's say in 100 milliseconds, and switch over to an alternative route. So you can realize repair times in your network within 100 milliseconds, or let's say 200 milliseconds, depends on how fast the routers are speaking that protocol. This is normally also implemented in hardware because software is still not that fast. We can also speak that, because if a router speaks that or wants to speak it with the neighbor, we have to speak it with our tool also, else the router won't speak with us. Yeah, so we have a real fast failover detection with this kind of protocol. It works something like that. And they send every 50 milliseconds, they send packages to their neighbors. Both of them do that. And if there are no packages coming in for a configurable, let's say 3 packages missing, you can configure that. Then the route is, or the link is configured dev, and the router can switch to an alternative route. And that's also, it's the time it got an RFC standard. It's just 2 months ago. Then you just read some blog and saw, hey, there's a new protocol, new add-on to the routing protocols, and just looked at the packet format. Oh, it's easy, and 3 or 4 hours later, it was implemented. So you will probably not find it in the wild already because it's a pretty new standard, but it will for sure it will show up in some environments having high requirements on failover times, which cannot tolerate a downtime from a minute or something like that. Then most likely this protocol will show up there, and Loki can handle this attacks too. So, yeah. So what's going on with Loki? Loki is still work in progress. So although there are lots of protocols already implemented, there will be upcoming features, which mainly are new protocols. Already on the to-do list are stuff like ISIS, GLBP, SNMP to implement. And just to complete the suite, we will also add protocols already supported by other programs like VTP or DTP attacks, spanning tree attacks, DHCP. There are several tools already supporting that, but yeah, to complete the suite, to have one suite to attack infrastructure protocols, we may add them also. And whatever infrastructure protocols we need to support, to attack, they will maybe get implemented. If you have some suggestions, maybe, oh, there's an infrastructure protocol nobody can attack, there's no tool, but it should be possible, just drop us an email and maybe we will implement that stuff also. Yeah, and of course there will be bug fixes. The whole tool is released today, now, for the first time in the world, except mentioned 2 modules which have some legal issues, so we can't release them yet. Maybe we'll do, maybe we will not. Current version is 0.24, and that's the link where you can download the source code. And we also built some Ubuntu and some Gentoo packages to be easily installable. So if you want to play around with that, just install some Ubuntu Live distribution, grab the packages, install them, and then you can play around with that. Maybe there will also be Windows version or a Mac version. We're not sure about that yet, but maybe we'll do that too. Yeah. Conclusions. So let's call Loki a new kid in the infrastructure attack block. So a new tool closing another gap between theoretical attacks and make it impractical usable. I know the attacks on OSPF and EIGRP, it was no secret that it's potentially attackable, but now you can use it with some mouse clicks with an easy tool. And another thing we want to tell you, okay, now it's possible to attack these protocols, so protect your infrastructure, but always think about the operational impact. Think about what does it mean for the guys operating your network if you implement the new security features, and don't just implement everything some smart white papers tell you or recommend you to do. So always get a good mixture of improving your security, but don't highen up your operational things you have to do. And also about, because of the infrastructure modularized infrastructure, go out and write your own Loki modules. You can write them in Python. It's not that difficult. For sure you have to know the protocol, but yeah, you can implement other modules, maybe in a cracker for other hashes, or whatever you need. Yeah, and of course have fun at the Black Hat. Yeah, and thanks for your time. Thanks for coming around. Hope you enjoyed the talk. And yeah. A last point, thanks Ollie for contributing the real CCP work. It was part of his diploma thesis. to figure out that stuff, and Flo for all the awesome eye candy he added to our technical presentation. He pimped it a little bit with all the nice pictures and stuff. He has can quite do this really good. So also thanks to these guys to contributing that stuff. Thank you.